Okay, we're going to do some subtraction algorithms, and just like I showed you base 10 blocks when we were adding, so you could understand how you carry the 1 and how that looks like physically when you do it with objects, you'll be able to understand the borrowing or the regrouping that we do with subtraction once you see this one worked out. So again, I'm not going to attempt to draw this in the video. I'm just going to demonstrate it. I've got drawings in the answers that I posted. So I've got 245 and I want to subtract 76. So what I've got laid out here is 200s, there's my 40, my 4 10s, and then I have 5 little ones. Okay. What I need to do here is I have to take away 70 and I have to take away 6. And it doesn't matter which one you do first. It really doesn't. But there's some regrouping and some borrowing is going to have to happen. So the first thing is, maybe I want to take away the 70 first. I'll start with that one. Well, I'd love to take away 70, but I can't because I only have 40 right here. The only way I can get to 70 is if I break this guy down. So I've got to take one of my hundreds and I have to trade it in for 10 10s. So I'm going to take my 100 and then I'm going to put in its place these 10 10s, and you can count them as I put them up here to make sure I've got all the right amount. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 10s plus the original 4 that I have. Now I have 14, and I want you to remember that. 14 10s here. So now I can take away 7. 1, 2, 3, 4, 5, 6, 7. No problem. Those are gone. Gone. So I took away my 70. Now I need to take away my 6. Well, the problem is I can't take away 6. I only have 5 unless I break one of these guys down. So maybe I should borrow one of these and break it into 10 ones, and then I'll have a whole bunch of ones. So I'm going to trade this guy out for 10 ones. There's my 10 ones. Okay, there should be 10 of them there, plus the 5 that I originally had, so that's 15. And I need to take away 6. So I go 1, 2, 3, 4, 5, 6. Okay, take those away. Those are gone. Gone forever. And we can look and see what's left. I have 100. I have 1, 2, 3, 4, 5, 6. That's 60. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9. My answer is 169. So now when we do the standard algorithm, I want you to think about everything we just did. So what do we tell kids to do? We go, well, you try to take 6 away from 5. Well, we can't. So we need to borrow from the next guy. So we need to take one of those blues and break it down. So then there's only going to be 3 blues left. And when you put your borrowed 1 over here, it makes that turn into 15. And remember, we had 15 purples. And I took away 6 of them, and I was left with 9. And then I don't have enough blues to take away 7. I only have 3. So you borrow from the hundreds, leaves you with 100, which is what's left. And when we add those 10 over here, we're going to have 13. We're going to have 13 ones, which I think we had 14 because we did the 70 first and then the 6. But you'd have 13 of these ones. If you take away 7 of them, you'd be left with 6. So you have 9 purples, you'd have 6 blues, and then 1 pink left. And so that explains kind of the regrouping that we did. I think the way we did it, let me show you one other way. I think we borrowed all the way from the hundreds first. So we said you can't take 6 from 5, you can't take 7 from 4. So we started here. And we had 14 blues. And then we borrowed one of those, leaves us with 13 to give us 15 ones. It's a slightly different than how we did it, but you get the idea that when you can do this like physically with your hands, it helps make this standard algorithm make a little bit more sense. Then we have another one called the equal addends algorithm. This works really nice if the numbers are messy. And it keeps you from having to do all the borrowing and the regrouping and all of that. So with subtraction, what you can do is either add the same amount to both numbers so that the second number ends in a 0. If this bottom number ends in zeros, you won't have to regroup or borrow from the top. Or you're going to subtract an amount from both numbers so that the first number ends in a 9 or a 99 or a 999. If you can get 9s on the top, you also won't have to borrow. So that's kind of the strategy here. So let me do, on this first one, let me do this subtract an amount from both numbers. So if I want this to end in a 9, okay, so instead of 520, if it was 519, I could subtract 1. I'm going to subtract 1 from both. And that's going to turn the problem into 519 minus 213. And by doing that, you can see you don't have to borrow. 9 minus 3 is 6. 1 minus 1 is 0. 5 minus 2 is 3. And you end up getting 306. And you can do it without having to regroup. But you have to do the same to both top and bottom. When we did addition, you had to add one and subtract from the other. But because this is subtraction, it takes care of itself. So you can do the same thing to both top and bottom. So we subtracted an amount. You look at example B, we'd have to do a whole lot of borrowing and regrouping because of all the 9s on the bottom. So why don't we try to get the second number to end in 0? So I'm going to try this adding an amount to both numbers on this part B. So I want this to end in zeros. So it's 299. Well, why don't I just add 1? If I add 1 to the bottom, I add 1 to the top. And so that makes it 752 minus 300. And because of the zeros on the bottom, we don't have to borrow. 2, 5, 4. The answer is 452. So if you have a student that just absolutely cannot get the regrouping strategy down, this gives you another tool in your toolbox to share with your students. All right, this one, we have 803 on the top, we have 459 on the bottom. We can make it so that the top number has a 9 in it, or we can make it so the bottom one ends in a 0. I decided to just subtract 4 from both. I know that seems random, but if you subtract 4, it makes the top 799, and look at all those beautiful 9s. And then the bottom will be 455. And you can subtract that without regrouping. 344 is what you would get for that answer. Sorry, there we go. Now you can see it. 799 minus 455 does not require any borrowing. And then the last strategy is called counting up. And this has also been referred to as the cashier strategy, like when people count back money to you, this is kind of what they're doing. So if you want to do 100 minus 31, you start at 31 and you think, well, what would I have to add to get up to 100? And you don't have to do it all in one jump. You can take small bites. So just add to the next nice number. So if I wanted to get from 31 to the next nice number that ends in a 0, like 40, I would add 9. And then that would put me up to 40. And then what would I have to add to 40 to get 100? 69. And then you just, oh, I'm sorry, it's 60. Sorry. My brain jumped ahead. 60 plus 40 is 100. And then when you add those together, you get 69. So you'd add 9 to get up to 40, and then you'd add 60 to get up to 100, because you're trying to get up to 100. From 31. So this is very like missing addend like, because we're turning it into addition. Let's see if we can do another one. I want to count from 24 up to 50. So maybe I could do 24 plus, maybe if I add 6, that would get me to 30. And then once I'm at 30, how much would I have to add to get to 50? I would only have to add 20 to get to 50. And I take these two, and my answer is 26 because I was trying to count up. You can also go like this: 24, 34, 44, and then from 44 up to 50 would be another 6. So 26, you can count up that way too. But this is sometimes how change is counted back to you in retail places. So that's called counting up. 3 different strategies for Well, I guess it was 4 different strategies for subtracting. Base 10 blocks, the standard algorithm, equal addends, and then counting up.